All right, so would this equation be considered even, odd, or neither? And so there's a few different ways to figure it out. Remember, even functions have y-axis symmetry. Odd functions have origin symmetry. And those symmetries conflict with one another, so if it has one, it can't have the other. So you can look at the graph. All right. Another way to do it, and that would be a little bit more challenging for a question like this, would be to find or determine whether f of negative x is equal to f of x. That's for an even function. For odd functions, f of negative x would have to be equal to negative f of x. All right, that one's a little bit problematic in this case because what we're looking at is not necessarily a function. It actually, I mean, it is, but it might not be because it's not solved for y in terms of x. You'd have to do a little bit of work to determine whether or not it's a function first, and then to see if these function rules apply. All right, I'll do it both ways. All right, so if we're doing it using this test, the analytic test, we would look at 2x squared plus 3y equals 6. I'd solve for y. I'd subtract the 2x squared from both sides. So 3y is equal to negative 2x squared plus 6. I would divide everything by 3. So we're looking at a parabola here. All right, I'd write it as f of x. All right. Then I would compute f of negative x, which is to say replace the x with a negative x and simplify. All right, if you square a negative, it becomes positive. So this piece here is just going to remain an x squared. Everything else is just going to kind of fall down around it. What we're looking at are two expressions that are exactly the same. And what I mean by that is the original function and post-computation are identical. All right, so that satisfies the rule for an even function. So this is an even function. All right, but in order to be an even function, it would have to be a function first. All right, you could still have an equation that's even, odd, or neither based off of the same spirit of the rule, just not exactly the same rule itself. And so that has to do with symmetry. So we'll take a look at the equation in the calculator. And we are looking at something that has y-axis symmetry. So if I plot, x equals 0. To plot the y-axis, I'll make it a nice dotted line. If it'll let me. Come on, touchscreens. If I were to fold the left part of this graph over the y-axis, it would merge with the right side. If I took the right side and folded it over the dotted line, it would merge with the left side. All right? So because it has y-axis symmetry, that would be another justification for it to be an even function. All right. But again, in order to say a function is an even or an odd or neither function, it would have to be a function to begin with. All right. Now, next one, Bill purchases a TI-84 graphic calculator for $150 in 2015 and sells the same calculator to Ted for $45 in 2020. Ted wishes to sell the TI-84 to Rufus in 2024 to earn full credit. Answer each of the prompts below. What is the equation of the linear depression model? Write your answer as a function C of t, where C represents cost and t represents time. Well, let's start off with something more basic. Let's start off with just an equation. It's linear, so I'm going to use y equals m times x minus x1 plus y1. We need 3 ingredients. the slope, the x value of an ordered pair, and the y value of that same ordered pair. Okay? So I'm looking at years versus dollar amounts, where years would be a predictor of the dollar amount. So 2015, 150, 2020, 45. All right. Now, I could, if I want to, I could let 0 be equal to the year 2015 and go from there, but I mean, calculators existed before the year 2015, so if you want to get, unless you want to get negative values involved for the measure of time, you could play it safe and just go with the year value. All right, so m would be equal to 45 minus 150, change of y, change in x, 2020 minus 2015. Crunch those numbers, just pop it right in. 45 minus 150 over, you just do 20 minus 15 because it's really a 5-year difference. So we're looking at negative 21. Then choose one of the two coordinates to call x, y. All right, we reviewed this a bunch of times. These numbers look a little nicer, so I'm going to go with those. So we're going to call these x1, y1. Oop. 1, y1. All right, so y equals negative 21 x minus 2020 plus 45. When you're writing the equation of a line, your x1, y1 is a point that you know is on the line. It does not matter what that point is as long as you know it's on the line. So we're almost done with this part of the problem. They said C of t, where C represents cost and t represents time. So instead of x, y, they're saying t, C of t. So t is taking on the role of x, C of t is taking on the role of y. Almost wrote an x again. So for the sake of organization, I'll just call this part A. Now it says state a practical domain for this function. Well, purchases a TI-84 graph and calculator for $150 in 2015. It didn't say it was a brand new one. All right, that's the thing that makes it a little trickier, but it also gives us a little wiggle room where it says state a practical domain, not state the practical domain. All right, so answers vary, and depending on whether or not your answer makes sense, you could get full credit and have an answer that looks completely different from mine, right? In fact, you would get full credit as long as your answer makes sense. And that's because, again, it says state a practical domain. All right, so if we operate under the assumption that it's a brand new calculator, we could say that the lowest possible value of time would be 2015. And the highest possible value, I don't know, when would you stop caring about a calculator? We know this guy Rufus is going to buy it in 2024, which is 9 years later. I don't know how much it's going to be worth then. We're going to figure that out in a few minutes. But, you know, something big. I mean, you could say 2050, 20, something more than 2024, maybe 2030. You really can't be wrong for this one as long as it's sufficiently large. All right. So if it's used, you might dial this number back a little bit. You might say maybe, okay, we got it a couple of years used. Maybe it's 2012. But the high end is still going to be subjective. 2030 is fine. Because it, like I said, it's subjective. All right. So it's not quite a gimme, that particular question, but it's pretty close. All right. Ted wishes to sell it to Rufus in 2024. How much should he charge if there's a linear depreciation in value? All that's asking us to do is figure out, based off of our equation here, how much this calculator is going to be worth in 2024. So here's my model. Now let's figure out, oh, I hit the wrong thing. Eesh. Where am I? That's the unit notes. Okay, we got there back there eventually. So C of 2024. So negative 20, and then replace the T with that 2024. So 2024 minus 2020. So 2024 minus 2020 is going to be 4. 4 times negative 21 is negative 84 plus 45. Yeesh. He'll be lucky to get anything for this. Negative $39. All right. So how much should he charge? He should charge $39. All right, that's how worthless this thing will be. So according to the linear depreciation in price, the linear depreciation model, which tells us that there is a linear depreciation in price, this calculator, which is declining at a rate of $21 every year, that's what the slope is telling us. It's losing a value of $21 every year. If it's only worth $45 in 2020, in 2021 it's only worth $24, then it's worth $3 in 2022, then negative $18, and then you get to your negative 39. All right, so what that actually means contextually is that not only should he give Rufus this calculator, he should also hand him $39 along with it for his trouble, for taking it off his hands. All right, now if he gets anything for the calculator, then he's ahead of the game. All right, because it's really, according to this model, it's really less than worthless. All right, so how long will it take for the calculator to have a value of $0? What that's saying is take your linear depreciation model and set it equal to 0. So replace the cost value with 0. And solve. You do that algebraically, you can do it on the calculator. I'll do it algebraically because I've done everything else algebraically here. So subtract 45. So we're looking at negative 45 equals negative 21 times t minus 2020. Let's get rid of that negative 21, divide both sides. I know it's not going to divide in cleanly. I mean, it'll simplify, but it's still going to give us a decimal answer, so I'll just leave this as 45 over 21 for the time being. Add 2020 to both sides. And so we'd be looking at t equal to 45 over 21 plus 2020, so 2020.143-ish. All right, it says how long will it take? Well, it's not going to take 2,000 years, 2022 years, 0.143. All right, if the calculator was purchased in 2015, that's telling us to knock off 2015 from this. So 7.143 years. All right. So definitely a trickier, more involved type of question, but one that you can kind of reason your way through. All right, but let me just show you really quickly. If you needed to do this on the calculator, you already have the equation. So you compute the slope, you get your equation. I'll write it as, you can still write it as C of t, so I'll just do that. So negative 21 paren t minus 2020 plus 45. So we have an equation there. It doesn't show up on the graph because the numbers are so large, but if you zoom out a lot, it will. You know, eventually. There it is. Alright, so it looks like we're kind of living in this neighborhood here in terms of the x-intercept. Alright, the x-intercept, if you're looking at part D, that's when C of t is equal to 0. So if you just tap on that, it'll give you the solution. And we kind of worked hard to get it. Desmos is like, you didn't really have to work that hard. Alright, so that's kind of nice. I mean, it's nice, but it's also like, kind of wish I didn't work so hard. Right? But the other thing that you can do for part C, see how we wrote C of 2024? Just type that in. You get your negative 39. All right. If you're ever nervous about the kind of work that you're showing on a test, you could always ask me. I'll absolutely tell you. But if you don't want to ask, you could always keep this in mind. It's not an algebra course. All right. This course does not have algebra in the title. I don't need to see the algebra. All right. Some questions will say show all steps and stuff like that. In the case of where is it? This bad boy here, that I need to see the work, and the question on the test will tell you to show the work. But if it just says write the equation, answer this question, answer that question, just only answer what you're being asked. All right. It's not designed for you to jump through too many hoops. All right. Write the equation of the piecewise function. Well, we have three pieces. So f of x, I'm going to make my open squiggle, enough room for three pieces. I'm going to write the equation of each part. All right. So the easy ones are the linear ones. This one has a value of y equals 2. It's a horizontal line, going from 0 to 2. All right, so that's actually the second part, so I can chuck that in right away, but I'm going to hold off. I don't even know why I wrote a 0 there. All right. The parabola looking one, it might be a little trickier, but if you have the idea in your mind that it is a parabola, then you should be in pretty good shape. All right, so that's really the key right there. Now, when it comes to writing the equation of a parabola, we follow the model. So again, for the parabola, y equals a times x minus h squared plus k. We're looking at an hk value, because hk represents the vertex, of 0, 0. And a is the 1 unit slope. So if I'm going out 1 unit to the left, which would put me right here, because I can't go to the right because it's truncated, I want to go up to the graph and see what that gives me in terms of a slope. All right, this has a rise over run of -1 over 1. All right, but we only care about the absolute value of that. All right, because this parabola could have gone the other way too. Right? It's whether the parabola opens upward or downward that dictates if A is positive or negative. All right, so this is a parabola that opens up, therefore A is positive. All right, so when we write our equation, we're going to replace the A value with a 1, the H value with a 0, and the K value with a 0. So we have what we need there too. All right. The last one, for any kind of line where the slope is not 0, because we're not concerned with the cases where it's vertical, because that wouldn't be a function. So the only other instance would be some kind of slanted line. We follow y equals m times x minus x sub 1 plus y sub 1. And we talked about this enough where it's, well, okay, m is the slope, so change in y over change in x. So I got a change in 2, another change in 2, so that's a slope of 1. Grab a point that you know is on the line, this is the point, 2, 0. X1, Y1. So x minus 2 plus 0. And then simplify if you want, but you don't have to simplify if you don't want. All right? That's not the point behind this question. So, working from left to right, I'm going to write 1 parentheses x minus 0 squared plus 0. That's this part of the parabola. Then a 2, because again, we only look at the right side of each of these equations, because this takes on the role of y. All right, the f of x is really the same as saying y. And then 1 parentheses x minus 2 plus 0. All right, that truncated parabola goes from a negative 2 to a 0. Solid point here, so it's a less than or equal. Open circle at 0, so that's a less than. All right. The horizontal line goes from 0 to 2. Both of those points are included. So 0 less than or equal to x less than or equal to 2. And then the last piece starts off at a 2, goes to a 6, open circle on the 2, closed circle on the 6, and this monstrosity here is our piecewise function. All right. And yeah, when we talked about this during lecture, it became apparent that writing the equation from the graph was definitely a more complicated process than doing it out by hand, because by hand could be a Desmos submission. You could also just make tables of values and go from there, but if you look at this one, you can see that there's a lot of ingredients to it. But if you break it up, if there's multiple ingredients to it, you might be more inclined to go with Desmos just because of all the different pieces that are there. But it's easy enough to do by hand also. So we have y equals negative 1, y equals 2, y equals x squared, and y equals 3x. All right. That first piece is only for values of x that are less than negative 2. So I want the largest value in my set to be a negative 2, and I would only be including values that are less than that. So negative 3, negative 4, negative whatever you want, as long as it's less than a negative 2. All right, that negative 2 is going to have an open circle when we plot it, because less than symbols always get open circles. All right, now this equation is y equals negative 1. That's saying that no matter what the x value is, y is always equal to negative 1. All right, you can plot it, y equals negative 1, and you can see no matter where you go, the y value is always equal to a negative 1. All right, now if you want to type this in with the domain, you'd open the squiggly bracket, x less than negative 2, and now you lock that in. But the thing is, it's not going to plot it with an open circle. All right, so when you're putting this on graph paper, or freehand sketch is fine too, as long as it's kind of reasonably scaled. X, y, we're going 2 to the left, 1 down. I plot an open circle here and then draw a horizontal line. See, look at that. Look at that awful horizontal line. It didn't even autocorrect to a horizontal line. There we go. That's more like it. All right. So if I'm doing it on Desmos, I got to get an open circle there. So I plot negative 2, negative 1. I'm not concerned with the color. I just care that it's an open circle. All right, so long press on the icon on the left-hand side, that point icon, and plot it. All right. The second piece, y is 2 if x is equal to negative 2. Well, when they tell you that y is a number when x is another number, That's an ordered pair. It's saying negative 2, 2. So at negative 2, 2, it's saying plot a point. Negative 2, 2. Oh, you know what? I just realized for the previous one, I plotted it at negative 1, negative 1. Apologies. Negative 2, 2 would be right here. I knew I was off with my first equation because it would have failed the horizontal line test. I'm sorry, horizontal line. It's getting late. Vertical line test. I was thinking of something else, obviously. So then I would just plot negative 2, 2, because it's just a point. Again, color doesn't matter. All right. Y equals x squared. We're plotting that from negative 2 to 2. Open circles on both ends. Negative 2, negative 1, 0, 1, 2. So I need an open circle for each of these. This one and this one. All right, so open, open. And that's because it's less than in both cases. So negative 2 squared is 4, negative 1 squared is 1, 0, 1, 4. I can plot those points, negative 2, 4, 3, 4, with an open circle, negative 1, 1, 0, 0, 1, 1, 2, 4, with an open circle. Nice smooth curve going through it. All right, on Desmos, y equals x squared. Open your squiggly. Negative 2 less than, just a less than symbol, not less than or equal, x less than 2. The one thing that nobody ever really likes about doing it on Desmos is the fact that it doesn't put the open circle there for you. Now, I mentioned this during lecture, that if you can't remember open circle versus closed circle, just drag along the curve to the endpoint and it'll produce an open circle for you if an open circle is appropriate. The only issue is it's impermanent. So you would know, okay, I got to put a point there at negative 2, 4. It would be nice if it kept it there, but it doesn't. I don't know why. So then 2, 4, open circle, and so now we have those pieces. All right. So then y equals 3x from 2 on. So x, y, so starting off with 2, maybe 3, 4, 5, 6, whatever. So 2 times 3 is 6. 3 times 3 is 9, 12. That's going to go off the grid big time. So I stopped caring after a while, but now I feel obligated to write them in. All right, so I plot 2, 6. That'd be like up here. Drag it down a little bit, create some more room. And then, you know, all you need are 2 points and a ruler when you want to draw a line. So 6, 7, 8, 9, just kind of get you a good ballpark sense. This one goes on forever, so I'll slap an arrow on it and call it a day. All right, I'll extend my y-axis, make it look a little nicer, bring the y up a little bit more. That's one of the benefits of waiting until you've computed all the points before you start drawing your graph, but I got a little impatient. So y equals 3x, open your squiggly. We're saying x is greater than or equal to 3. I'm sorry, 2. If there's a solid endpoint, see a solid endpoint there, you don't have to plot a new point for that, it's implied. All right, so this would be a nice piecewise graph. We don't have to worry about arrows if we do it on Desmos. So then all you do is make sure you're signed in. You have to be signed into Desmos, which means you have to have an account, signed in, then create the share link and submit that on Blackboard, and that would get you full credit on the test, or for this problem on the test, of course.